In this particular question, a thin rigid pole is being carried horizontally around a 90-degree angle with hallways that are 1.2 meters wide and 1.6 meters wide respectively. So this hallway is 1.6 meters wide and this hallway is 1.2 meters wide. We want to figure out the longest length of pole that can be carried around there. And the question says no domain analysis will be necessary. Well, one of the things that we learned is that this angle is going to be equal to this angle. If I make an imaginary horizontal line here, the angle made by the pole with this imaginary horizontal line is the same as the angle made by the pole with this wall. And we're going to call that angle theta. And we know from trigonometry that the sine of theta is 1.2 over L1. L1 represents this length of the pole. And so because sine theta is 1.2 over L1, we can do a little rearranging and say L1 is equal to 1.2 over sine theta. Similarly, we can look at this angle theta and say that cos theta is equal to 1.6 over L2, where L2 is this length of the pole. So cos theta is 1.6 over L2. Doing a little simple rearranging, we get L2 is 1.6 over cos theta. Now we can see that the length of this pink pole is equal to L1 plus L2. So in other words, L at theta is equal to 1.2 over sine theta plus 1.6 over cos theta. Now we can re-express this this way if we like, and now we're going to differentiate this expression and set it equal to 0. So the derivative of 1.2 sine theta to the negative 1 will be negative 1.2 block to the negative 2 times the derivative of the block. And then the derivative of 1.6 times cos theta to the exponent negative 1 will be negative 1.6 block to the negative 2 times the derivative of that block. Now we want to set that derivative equal to 0. So we can say negative 1.2 sine theta quantity to the negative 2 times cos theta. This negative sine theta multiplies that negative 1.6, so we get plus 1.6 sine theta times cos theta to the exponent negative 2 is equal to 0. This is on the left-hand side, 1.6 times sine theta over cos squared theta. I can make that exponent positive and put it in the denominator. That's on the left-hand side. And then on the right-hand side, I can bring this over, as they say, or add it to both sides. And what I get on the right-hand side is a positive 1.2 cos theta over sine squared theta. By putting that in the denominator, it becomes a positive exponent. Multiplying both sides by sine squared theta and multiplying both sides by cos squared theta, I get this expression here. And now we can divide both sides by cos cubed theta and divide both sides by 1.6. So we have sine cubed theta over cos cubed theta is 1.2 over 1.6. And on first glance, that's going to look pretty tough to do, but then we remember that sine cubed theta over cos cubed theta is really tan cubed theta. Tan cubed theta equals 0.75, which means tan theta is the cubed root of 0.75, which means theta must be approximately 42.3 degrees. So the length of the pole that we had on our previous page, we just have to plug 42.3 degrees in for theta and evaluate. So that's what we do. L at 42.3 degrees will be 1.2 over the sine of 42.3 plus 1.6 over the cos of 42.3, and that comes out to approximately 3.9. That is the maximum length of pole that can be carried horizontally around that corner. Now for the next question, this is a prison break question. And so what's going on here is imagine that someone has to prop a ladder over top of a 5-meter tall wall, which happens to be 3 meters from a fence. And then this ladder, if the person can climb this ladder and get to here, they can just climb the fence regularly, just climb the fence, and they'll be able to escape jail. But what they want to know is what is this, what's the minimum length of ladder that they'll need. So we're going to use a little calculus for this. We're going to break the ladder up into two pieces, L1 and L2. And we're going to see that if we make an imaginary horizontal line here, that the angle made is theta. The ground is a horizontal line, and this angle will also be theta. And we can see that looking at this one here, looking at L1, we can see that the cosine of theta is going to equal 3 over L1, which means that L1 is going to equal 3 over cos theta, doing a little simple rearranging. So the length of this part of the ladder is equal to 3 over cos theta. The length of this part of the ladder is going to be derived by similar trig manipulations. We see that the sine of theta is equal to 5 over L2. And so that means that L2 must be equal to 5 over the sine of theta. And so since our length is equal to L1 plus L2, we can say that L of theta is equal to 3 over cos theta plus 5 over sine theta. Now, we can re-express that as this way. We can say L at theta is equal to 3 times cos theta quantity to the negative 1 plus 5 times sine theta quantity to the negative 1. We're going to take the derivative of this expression, and using the chain rule, we have negative 1 times 3 is negative 3 times cos theta quantity to the negative 2 times the derivative of that block, which is negative sine theta. In other words, 3 block to the negative 1 has a derivative of negative 3 block to the negative 2 times the derivative of that block. Similarly, 5 block to the negative 1 has a derivative equal to negative 5 block to the negative 2 times the derivative of that block, which is cos theta. So we see that L prime of theta is actually equal to, since this negative 3 and this negative sine theta multiply, it becomes positive. We have 3 sine theta over cos squared theta, and then this becomes negative 5 cos theta over sine squared theta. We're setting that derivative equal to 0, which means we can say 5 cos theta over sine squared theta equals 3 sine theta over cos squared theta. Multiplying both sides by cos squared theta and multiplying both sides by sine squared theta, we get 5 cos cubed theta equals 3 sine cubed theta. Dividing both sides by 3 and dividing both sides by cos cubed theta gives us this expression. And again, we see that the sine cubed theta over cos cubed theta is equal to tan cubed theta. So 5 over 3 is equal to tan cubed theta, which means the cubed root of 5 over 3 is equal to tan theta. Doing a little tan inversing on our calculator, we get that theta is approximately 49.9 degrees. And now we can go up to this expression here and plug 49.9 degrees in there. 3 over the cos of 49.9 degrees plus 5 over the sine of 49.9 degrees is approximately 11.2, which means that this person who's trying to escape from jail needs a ladder that's at least 11.2 meters long approximately.